Hello class, I want to once again welcome you to today's session. Today we're looking at Module 12, Network Security Infrastructure. Network Security Infrastructure. And in this class, we are going to be looking at the concept of network, local area network, metropolitan, wider area network, and we're going to be looking at the components that actually makes up a network. Now, over the class or in the lesson, we're going to be making use of certain devices, and these devices are grouped or categorized into two. We have what we call the end devices, we have the intermediary devices, and we have the network media. Now, these are the symbols that we're going to be using to represent them. Once you see this, you know it's a desktop. Once you see this, you know it's a wireless tablet. Once you see this, it's a printer, and so on and so forth. Now, end devices, we have talked about it in our last class, where we specified that they are usually the source of the traffic or the messages, or they are the destination of the message. And usually you identify them with an IP address. Now, intermediary devices, once you see this, you know it's a wireless router. This is a multi-layer switch. This is a local area network switch. This is a firewall appliance. This is a router. Now, we said intermediary devices help to control the movement of this traffic, okay? The movement of traffic and control to where they go, how they go, the alter, the performance, and things like that. Then network media, once you see this, you know it's wireless. Once you see this, you know we're talking about LAN. And once you see this, we're talking about wider area network media, all right? And the network media basically is the channel in which this data is conveyed or is carried along. Now, the important terminologies that we need to know are the network interface card, we have the physical ports, we have the interfaces. Okay, the network interface cards, most of them, we find them in all devices, like our end devices. You see network interface cards. In our intermediary devices, we have what we call the physical ports. We also have the interfaces as well. All right, so we're going to be making use of them. Now, a topology actually describes the nature of the network, the way the network is designed, and how the traffic is actually moving. Now, the physical topology explains how those devices are connected. That's the end devices, how are they connected to the intermediary devices, and how are the network media connecting these intermediary and end devices. All right, so the physical topology basically gives us the layout of the network and how the devices are communicating, while the logical topology actually describes to us the addressing scheme and how traffic actually moves across the network. Okay, where are the end devices and where are the gateway and where do the routing take place and things like that. So the logical topology and the physical topology actually are important in any network design, because you will need to understand how the devices are interconnected, and then you need to understand the IP topological layout as well as how the traffic actually moves. Now, we have different sizes of networks. We have the small networks, we have the small office home network, call it the SOHO. We have the medium size or large networks, and then we have the worldwide network. Now, in any case, in each of these setup, all right, what differentiates them is the size or the coverage of the geographical area, as well as the kind of devices, or rather the physical topology. All right, the kind of devices or the physical topology that is being made. Now, small home networks actually connects few computers to the internet, like you can see here. And a small office actually enables computer within a home office or remote office to connect to the network. Okay, then medium-sized network can have many locations with hundreds or thousands of interconnected computers, while the worldwide network connects hundreds of millions of computers worldwide, such as the internet. Now, the network infrastructure may vary, all right, like we said, depending on the size of the area covered, or the number of users that are connected, or probably the number and types of services that are available on that. All right, that will help us to understand the concept of either a local area network or a wider area network. The two most common types of network infrastructure, like we said, are the local area network and the wider area network. Now, a local area network interconnects end devices in a limited area, or sometimes we can say a small geographical area. So you see, these are end devices. All these are end devices. This is also an end device. So in a small geographical area, a local area network interconnects these devices using an intermediary device under a single administration, or it is administered by a single organization or individual. That's a key element in the description of our LAN. And they also provide high-speed bandwidth to internet and actually end devices. All right, that is local area network. A wider area network, actually from the word wide, so it covers a very wide geographical area. Sometimes it covers a state, a country, you know, and things, or continents, as the case may be. So you see, it has, this is a LAN, this is a local area network, this is another local area network. So a WAN is an interconnection of LANs over what? Over a wide geographical area. So you see, this is the symbol that we said to cover a wide area network. So this is trying to tell us that this LAN is connected in a different location, and this one is connected in another different location, very wide, very distant from one another, and is typically administered by what? Multiple service providers. All right, while a LAN by a single individual organization. Now, whereas a LAN is it has high speed bandwidth because of the LAN. If you are using these cables here, maybe you'll be using Cat6 cable, which carries like 1,000 Mbps, I know. But a WAN usually has slower internet speeds because it depends on the internet subscription that you have with your ISP. Now, a campus wired local area network actually uses a hierarchical design. Now, a hierarchical design is a design that is layered. Yeah, you see, this is one layer. You see, this is another layer. This is another layer. So what it does is that it groups this particular devices into layers. Now, this grouping has to do with access layer or access group, distribution, and core. Now, what is the difference between the three? Now, you see, the access actually provides endpoints and user direct access to the network. Remember, you are dealing with end devices at the access layer. You see, all these ones are end devices. And you see, all these ones, they are end devices. and they are usually at the access layer because they are the ones that actually gain access to the network. So the access layer, you can use access points. This is an access point. This is another access point, like wireless access point. All right. This is like an access layer switch, you know, that actually provides LAN connectivity to maybe VoIP or systems and things like that. So that is the access layer. So it's like the final aspect. And in most of the cases, this is where the data is being generated from. Okay, your PDU or your data or your messages, this is like it's generated from, or they are like the target point. Okay, somebody wants to get like destination points or addresses for most of this traffic. Distribution actually does what? It aggregates access layers and provide connectivity to what? Services. Now, you see, within a network, within a local area network or a wider area network, there are services that needs to be accessed. Some of these services are, remember when we talked about the OSI model layer? When we talked about the OSI model layer, remember the services we talked about? You know, you can have a DHCP, it's a service. You can have a DNS, it's a service. You can have the web server, it's a service. Apache, that's the web server, it's a service. You can have eGranary, it's a service. You can have so many services that the end devices might wish to access. Okay, so the distribution layer provides connectivity to these services, right? Now the core layer provides connectivity between who? Distribution layers for a LAN and for large LANs environment. All right, this is like the core layer. So when traffic is coming in from outside, the core layer actually meets the edge, and it meets, that is where security policies are applied for external traffic and a lot of like gateway stuffs that happens here. When traffic from here are going out, they actually go out through the core layer, except if these services and devices are requiring services within the particular network. Although the hierarchical model has 3 layers, some smaller enterprise networks may implement a 2-layer hierarchical design. All right. Now, why do we say a 2-layer hierarchical design? Because you can have the access layer that is there. All right, so it collapses the core. So it takes the distribution and part of the core. All right, so that is like a 2-layer whatever. So the core and distribution layers are collapsed into 1 layer. Yeah, the core and distribution are collapsed into 1 layer, thus reducing the cost and complexity. Now, since we are looking at security of a network, sometimes firewall designs is primarily about device interfaces permitting and denying of traffic. This is basically what firewall is all about. To permit traffic or deny traffic based on certain things like source or the destination or the type of the traffic. Okay, so you can decide to permit based on source, destination, or type, or deny based on source, positioning, and type. Now, the public network, which is like your outside network, is usually untrusted, and the private network or the local network is actually trusted. So, for instance, this is your LAN. You trust your LAN because you are the one that manages. This is your WAN. This is what is coming in from the internet. You don't trust it because you don't know, you don't manage it entirely. So what do? You create a security point here. to say, okay, traffic that are going out from your trusted zone to the untrusted zone, you are free to permit them. Because they have as they go out, they don't cause any harm to your network. They are just going out. And then the ones that are coming in from untrusted into trusted, you deny them until you apply certain filters, until they meet certain demands. So one other way to go about it is to set up what we call a DMZ, a demilitarized zone. Now, a firewall design where there is typically one inside interface connected to the private network. This is the private network. So there is an interface connecting to the private network, and then you have one interface connected to the public network. This is the public network. So you see, this one is connected to the private network. This interface is connected to the public network. Then you also have what we call the DMZ interface. That's another interface that is connected to your demilitarized zone. All right. Now, the policies that you place, the security features that you place, applies here in the firewall. Because the interesting part is that, okay, when traffic is coming in from outside to the local, to the demilitarized zone, what is it you put in the demilitarized zone? You put all those services that you want to be accessed publicly. Any service that you want, maybe your web service, your DNS service, you know, all those services that you want to be accessed publicly, you place them here. That's why you see here is green. So they are free to go to the internet and come back, you know, without any issue. Internet can hit this place and go back. So on your firewall, you can permit traffic in and out of this place. But on your private network, it's very secure. Okay, so even things on the DMZ, you can, it is difficult. You apply firewall here when traffic is coming from the internet, and you apply firewall where traffic is coming from the DMZ. Okay, but you can permit traffic to go to the DMZ. You can permit traffic to go to the firewall. Now, there's what we call a zone-based firewall. And zone-based firewalls use the concept of zones to provide additional flexibility. A zone is usually like a group or of one or more interfaces. Okay, there are certain interfaces that you want to apply the same kind of policies. So instead of going to this interface and apply the same policies, then come here to another interface and apply another policies, like you see here. You see here. So instead of coming here on this interface, I begin to apply a series of policies. Then I come here, I apply the series of policies which are like the same. All I just need to do is I group them, these two interfaces, into one zone. Then I will apply the policy, security policy to that zone. Okay, to that zone, I apply the policy, security policy to that zone. So zones help to specify where a Cisco firewall, iOS firewall rule or policy should be applied. Now, what are security devices that we should bear in mind? We have what they call a firewall. A firewall is usually a system or a group of systems that enforces what? Access control. All right, between networks. All right, between your public network and your local network. Okay, so there are certain things coming from the public that will be denied. Okay, there are certain things that will be allowed to pass through. So some of the common firewall properties include resistance to network attack. You know, the only transit point between terminal corporate networks and external networks, because all traffic flows through the firewall, right? And then enforces the access control policy, all right? So you can give access control policy and stuff like that. So you do all that in the firewall. So you see, in the firewall, you can allow traffic from external address to the web server. The web server can be sitting on your DMZ. You can allow traffic to your FTP server. It will sit on the DMZ. You can allow traffic to your SMTP server. SMTP is your mail server. You can allow traffic to your internal IMAP server, which is also a mail server. But what are those that you should deny? Deny all inbound traffic with network addressing matching internal registered addresses. Okay? Deny all inbound traffic to servers from external addresses. Deny all inbound ICMP echo requests when somebody is running a ping, all right, to ping to verify whether your system is reachable or stuff. Deny all inbound Microsoft Active Directory queries. Deny all inbound traffic to your SQL server and queries. Deny all Microsoft domain local broadcasts. So, what are the benefits of firewall? It prevents the exposure of sensitive hosts. You have sensitive hosts, so it prevents them from being exposed. Okay? And then sensitive resources as well, and then sensitive applications to untrusted users. Firewalls also help you to sanitize protocol flow, which prevents the exploitation of protocol flow. Okay? Firewalls actually block malicious data from servers and clients, and then it reduces security management complexity. All right, those are the benefits. What are the limitations? A misconfigured firewall can have serious consequences for the network, such as becoming a single point of failure. Right? Another limitation is that the data from many applications cannot be passed over the firewall securely. Then another limitation is that users might proactively search for ways around the firewall to receive blocked materials, which exposes the network to potential attack. And then network performance can actually be slowed down. All right, with firewall, without firewall, you can move about. Firewall, you can slow down your network a little. Then unauthorized traffic can be tunneled or hidden as legitimate traffic through the firewall. Okay. Now, the firewall is usually applied in the network and transport layer, especially the transport layer. So packet filtering firewalls are part of a routed firewall which permits or denies traffic based on layer 3 and layer 4 information. Right? Layer 3 has to do with your IP addresses. Layer 4 has to do with your port numbers. All right, source and destination. They are stateless firewalls that use a simple policy table lookup that filters traffic based on specific criteria. So source IP address, destination IP address, these ones are for layer 3. Then protocol also for layer 3. Source port number, destination port number, synchronizing number, and and then packet, these ones are layer 4. Okay. So, but stateful firewalls are the most versatile and the most common firewall technologies used. All right, the one we just looked at is like the different types of firewall. That's what we're looking at. The one we just looked at is the packet filtering. All right, this one is the stateful firewall. All right, so These firewalls provide stateful packet filtering by using connection information maintained in a state of table. That is why the session layer is added to it. Okay, the session layer is added to it. Then we also have application gateway firewall. All right, application gateway firewall filters information at layer 3, 4, 5, and 7. All right, most of the firewall control and filtering is done in the software. Wow. Okay, so and we have firewall types like the next generation firewall, the NGFW. All right, the NGFW go beyond stateful firewalls by providing integrated intrusion prevention, that is IPS, then application awareness and control, and then upgrade path to include future intrusion feeds, and then techniques to address evolving security threats. Other firewalls of implementing firewalls, other methods of implementing firewalls include host-based firewall, which is like server and personal. All right, a PC or server with firewall software that is running it, or transparent firewall, usually filters IPs between a pair of bridge interfaces, or hybrid firewall, which is a combination of the various types of firewall. Okay, so now a networking architecture paradigm shift is required to defend against fast moving and evolving attacks. Okay, fast moving and evolving attacks. So a networking architecture paradigm shift is required to defend against fast moving and evolving attacks, and this must include cost-effective and prevention systems such as the intrusion detection system and the intrusion prevention system. Okay, so the network architecture integrates these solutions into the entry and exit points of the network. Okay, so as you can see here, the traffic comes, this is like the intruder. Okay, it comes from the internet, and then it comes through your edge router. Then once it meets the intrusion prevention system, it is blocked from here. The intrusion prevention system blocks it from going further. All right, this is like the firewall. If it passes through your edge router, it prevents from passing through here. But if it's able to pass through here and get to the management console, then the intrusion detection system will detect it and then trash it here. Okay, so the explanation of this is just to explain to us how it works. So what are the advantages between IDS and IPS? For the IDS, no impact on network. That means there's no need to, it's not going to affect your speed or your latency of your network. No network impact if there is a sensor failure. Then no network impact if there is sensor overload. All right, but what is the disadvantage of IDS? Response action cannot stop trigger packets. Correct tuning required for response actions, and then more vulnerable to network security evasion techniques. Okay, how about the prevention? The prevention stops trigger packets, and it can stem normalization techniques. but the disadvantage is that sensor issues might affect network traffic, and sensor overloading may impact your network. So some of the disadvantage of the IPS, we said sensor overloading impacts the network. Some impacts on network can cause latency or jitter. So IPS and IDS technologies can complement each other. That is, if you put both of them. Deciding which implementation to be used is excuse me, is based on the security goals of the organization as stated in your network policy. Okay, as stated in your network policy. So it's good to have both. But there are two primary kinds of intrusion prevention system. We have the host-based and we have the network-based. All right. The host-based is a software that you install on your laptop or your desktop or your server or your device, your host, and it will analyze security activities. So it provides, like when we talk about, what do we call it, this antivirus network security, provides protection specific to a host operating system and provides operating system and application level protection, protects the hosts after the message is decrypted. And the disadvantage is it's operating system dependent. So if you install the one from Windows, you might not be able to use it for Linux unless you get the version for Linux. All right, and it must be installed on a host. But the network-based intrusion prevention system are implemented using a dedicated or non-dedicated IPS service. All right. So the host-based IDS solutions are integrated with a network-based IPS implementation to ensure a robust security architecture. So sensors detect malicious and unauthorized activities in real time and can take action when required. Okay, so you have your DMZ here or your servers here. You have your local area network here. You can have a sensor. Then you have your firewall, and then you have a sensor. Right? Now, these are some examples of specialized security appliance that you can use. Cisco have the Cisco Advanced Malware Protection, and usually it's an enterprise class advanced malware analysis and protection solution. All right, and it provides comprehensive malware protection for organization during and after an attack. Then you have Cisco Web Security Appliance, and what it does basically is all right. Now we have Cisco Email Security Appliance. What it does is that it helps to mitigate email-based threats, and it helps to defend mission-critical email systems. So constantly is updated by real-time feeds from Cisco Talos, and it helps to detect and correlate threats using a worldwide database monitoring system. You know, it has a feature of global threat intelligence so that it can block spams and malware protection and stuff like that. Now, security services. Access control list is a series of commands that control whether a device forwards or drops packets based on information found in the packet header. Okay. When configured access list performs, what it does is that it limits traffic to increase network performance. It provides flow control. It provides base level of security for network access, and it filters traffic based on traffic type. Okay, so you see here we have PC1 to 3, and you see access lists are applied at the routers. So an access list is applied here, and what access list? It denies video to switch 1, okay, and deny access to switch 2 for switch 1. Now what we are saying is that if somebody here wants to run video, they will deny, you can deny video access, all right, and you can deny traffic from here to enter switch 2. That is an access list. Okay, here they say allow incoming email and deny incoming telnet. Woo! Excuse me. Okay, so the point we are trying to explain here is that access lists controls are being added to routers, and they are to control traffic either coming into the router or going out. So you see in this case, you see the access list is applied going into the router, meaning that any system on this LAN that wants to run video will be denied access. Okay, and then any traffic, any system here that wants to access any service in this LAN will also be denied access. So you see it's applied in this interface, right? Now you see if we come to this router 2 here, router 2 has 1 interface, 2 interface, 3 interfaces. Out of the 3 interfaces, there is the one that access this is applied is going out, going to the internet, all right, or is coming in from the internet into this interface. So you see it's allow incoming email. So if emails are coming in, the access list is permitting it to come in, but it's denying incoming telnet. If somebody is coming in from inside to do telnet will be denied. So you see, based on this access list, all right, it will be outside. Now, earlier on, we spoke about zone-based firewalls. When you are creating firewalls and you're talking about grouping them into zones, you can decide to create the access list in groups like this, and then you apply it. Now, when you come to router 3 here, you see it has 2 interfaces, okay? With these 2 interfaces, the access list is applied on this interface, you see, and what is it? Traffic coming in. Traffic coming in from this particular LAN. So it's denying this LAN update, it's denying them access to FTP, denying them access to web. All right, and then here it denies access to human resource. All right, so if a traffic is going to human resource, it's denying them access as well. Okay, now what access list is very, very important, because like we said, it controls your traffic, especially the behavior of the traffic coming into your network and going out of your network. And you see, when you are talking about network security, like we saw earlier, you have to deal with layer 3, which is layer 3, which is the network layer, layer 4, which is the transport layer. Now in the transport layer, we said it's going to be dealing with port numbers, and layer 3 is dealing with the IP addresses. Now we talked about where you deal with it in the session layer and in the application layer. But So generally speaking, when we are discussing the concept of access list, we have to talk about standard access list as a type, and then the extended access list as a type as well. So when we say standard access list, we are trying to say those type of access lists that are used to deny or permit traffic from source, which is IP version 4. All right, you are denying or permitting traffic from a source. But the extended access list is IP version 4 packet based on several attributes. Now, when we say several attributes, we are talking about these items here. It can be based on protocol. It can be based on source address, source IP version 4 address. It can be based on destination IP version 4 address. It can be based on TCP or UDP, or that's the protocol. It can be based on destination TCP or UDP. All right. It can also be based on, it can be optional protocol type information control. All right. So all this, once you are applying an access list or a security features that is dependent on this information, then you are creating an extended access list. But you see, the standard access list is just like a blanket rule. It's like when you place a military man at a gate and you just tell him no entry for non-military officers. So whether once you are not a military officer, whether you are a male, whether you are a female, whether you are a politician, whether you are not a politician, whether you are the president, or whatever it is you are, so far you are not a military officer, deny you access, you see? Or you can just go and say, okay, you are going to a party, you say, you only permit female, any other person deny. So it means it's a blanket. All females are permitted, whether it's white or it's black or it's Nigerian or it's European or it's whatever, tall, black, short, thin, all of them are permitted. So that is standard access. But extended, you have to be specific. You have to be specific. All right, you want to deny permit military persons to go out of the barracks. Then you say permit only sergeant with clearance of 2 days. So even if you are a sergeant and you don't have clearance of 2 days, you will be denied. If you are not a sergeant, even if you are a military man, if you are not a sergeant, you'll be denied. So you see, in extended, it's actually more specific. So standard and extended access lists can be created by using numbers or name, basically to access the access list statement. We're going to do a demonstration or a, what do we call it now? A lab activity very soon. Now, SMTP is one of the services that you can run on your network, and it has to do with simple network management protocol. And it's usually an application layer protocols that provides a message format for like communication between managers and agents. All right. And it allows network administrators to manage end devices such as servers, workstations, routers, switches, security appliances, and things like that. All right. It also monitors and manages network performance and find to solve network problems, plan for network routes. So the SNMP system consists of the SNMP manager and the SNMP agent. Those are the elements that are in SNMP. So you see, this is the manager, all right, where you install it on your device, your system, Then you have the agent. The agent are installed in any device that actually you need to manage. For instance, you want to manage it on your router, you install an agent. You want to manage a switch, you install an agent. You want to manage your firewall, you install an agent. All right? So the manager actually runs the management software. And then the agent actually are just nodes that are being monitored, because they are also going to be sending information. Another tool for network monitoring is the NetFlow. NetFlow is a Cisco iOS technology that provides statistics on packet flowing through a Cisco router or a multi-layer switch. All right, so you have a router here, you can enable NetFlow, and then it will give you statistics of traffic flowing through this router or through the switch. All right, so the NetFlow provides data to enable network and security monitoring, right? Network planning, traffic analysis to include identification of network bottlenecks, right? IP accounting for billing purposes and stuff like that. So NetFlow can monitor application connection, tracking bytes, and packet counts for that individual application flow. So it then pushes the statistics over to an external server called the NFlow collector. In this case, this is it. So the NFlow will push the statistics to this. All right. So NetFlow is another one. Then there's another tool called the port mirroring. So you see, we have talked about SNMP. We have talked about NetFlow. Now, port mirroring. Port mirroring is usually a feature that allows a switch to make duplicates of traffic passing through a switch. So you see, the traffic is coming from here to here. Then port mirroring will say every traffic that is passing through this switch, copy the traffic and store it here. All right, it will send it to this monitor, and this is the guy that will just be analyzing it. All right, so that is port mirroring. So you specify in port mirroring, you specify the ports you want to mirror. All right, you specify the ports you want to mirror. Now, another tool or service is the syslog server. Syslog has to do with system logs. System logs. In system logs is basically a machine or a server that keeps track of all logs of your router, logs of your switches, logs of your firewall, logs of any other device that you want to put. So it goes to syslogs. So it allows allows networking device to send their system messages across the network system log servers. And it provides three functions. One, gather login information, all right, for monitoring. And then select the type of login information that is captured. It gathers it, selects it, and then specify the destination of captured messages, right? We have another service or another tool. It's called the NTP. NTP has to do with time, synchronization of time, so that all your devices will be having the same timing. It is important to synchronize the time across all devices on your network. The date, time settings on your network device can be set using two methods, all right? Either the manual configuration of date and time, or you configure the network time protocol, all right? So the network time protocol uses a hierarchical system time source where each level in this system is called a stratum. All right, so NTP servers are arranged in 3 layers. Stratum 0 is the NTP network gets the time from authoritative time sources. Then stratum 1, devices are directly connected to authoritative time resources. Stratum 2 and lower stratas are devices such as NTP clients synchronize their time using the NTP packets from stratum 1 servers. Okay, another service that is good is called the AAA, AAA, Authorization, Authentication, and Accounting. All right, and usually you use that to administer, manage, keep logs, and control users who gain access to your network. So users and administrators must prove that they are who they are. That is what authentication does. So you have to enter a password. So authentication can be established using usernames and password combinations. All right, so AAA authentication provides a centralized way to control access to the network. So very, very, very important. Enter your username, enter your password. Enter your username, enter your password. Then B, authorization. After the user is authenticated, authorization services determine which resources the user can access and which operations the user is allowed to perform. All right. So the concept of authorization is to create limits on user accounts or user profiles. You create limits, you can access this, you are denied this, you access this. And then the accounting aspect keep records of what the user does, including what he or she accessed, the amount of time the resources is being accessed, and any changes that were made. All right, so accounting keeps track of how network resources are used. All right, an example is a user student access a host XYZ using SSH for 15 minutes. Okay. Below is the table list the differences between TACAs. TACAs is Terminal Access Controller Access Systems. All right, and radios. All right, radios is remote authentication, dial-in user service. Remote authentication, dial-in user service. What are the differences? TACA separates AAA according to their architecture, while radios combines authentication and accounting and authorization, but separates accounting. Okay. TACAs is mostly supported by Cisco devices, but radios is open standard. All right. TACAs is TCP, radios is UDP. TACAs is bidirectional challenge and response as use of challenge handshake authentication protocol. It uses chat. But radios is unidirectional challenge and response from the radio security server to the radio's client. TACA's entire packet is encrypted, but radios is only the password that is encrypted. TACAs provides authorization of routers command on per user basis, and radios no option to authorize router commands on per user group basis. And then TACAs is limited on accounting, and then radios is extensive on accounting. So you can use any one of them. Another service that can run security is VPN. VPN is a virtual private network that is created over a public network. You have a particular resource in your central office, and you want to access this resource over the internet from a remote location, either from a branch office, from your house, from your mobile. So you want to access this application through the internet. So the best way to do it is using VPN. Okay, so it uses virtual connection routed through the internet from organizations to the remote site. And a VPN is a communication environment in which access is strictly controlled to permit per connections within a defined community. Okay, so confidentiality is achieved by encrypting the traffic within the VPN. All right, in short, VPN connects two endpoints over a what? A public network. From a logical connection is made to one on layer 2 or layer 3. So in summary, we have seen that we need to understand our network very well to secure it, especially our layer 3, our layer 3, layer 4. We need to secure them very well. And additionally, layer 5 and layer 7. Okay, so we need to secure them very well. So thank you all for today's class. This is chapter 12. We'll look at chapter 13 next time. Thank you.